to give a quick example on how this is all going to work, we see here that we have a structure and some definition, and then we can create an instance of it, and then we can access its members using the dot notation. And so we'll get into more advanced uses of structures when we talk about dynamic allocation and how structures are used in that regard. But to keep it simple now, we'll do a very simple example with a statically allocated structure, and we'll use the dot operator to access its members. So let's say we want to have a collection of data to store various things for, what's a good example? I want to store at the time. So the time is made up of a few different things. Let's say we're looking at 12-hour time. So we have the hours, the minutes, the seconds, and then we'll have an AM or a PM like flag that lets us know which one it is, right? So if we think about, okay, cool, what do we need? We want to create a structure, and we want to call it, we'll call it time info, right? Now, in this structure, we need to have the hours. So we'll say, okay, what's an hour? It can be 0 to 12. So this is a very small value. We only really need 8 bytes. So we'll put it into a char. So we'll say char hours. Now, same for the minutes. And same for the seconds. Now, if we wanted to have like microseconds, nanoseconds, picoseconds, then we would need much, much larger data ranges than what the character offers us, since it only offers us, as it is now, as a signed character, 0 to 127. So it's not much, but it's enough to represent the hours, minutes, and seconds. But we're missing one thing, and this is the AM or PM. So if we remember back to the variables, talking about enumeration types, and so enumeration types give sort of semantic sort of meaning to human readable lines or identifiers in our code. And so we can say enum, so we'll say AM, PM, and I'll put a little E at the end so you know it's an enum. And so in here we'll say, okay, we want to have AM or PM, right? And we can then go and put this in here. So we'll have an enum, AM, PM, E, and we'll say this is the, I don't know what these things are called. Yeah, we'll just call it AM, PM. A bit confusing. Or we'll just say like time of day. It's a little easier to understand. So what we're saying here is that we're going to have some enumeration, and when this compiles, this will get, AM will essentially be given the value 0, and PM will probably get given the value 1 as the compiler sort of solves this. But we don't really care what these are. All we want to know is that, hey, when we query this object, do we know if it's AM? You know, if we get a 0, it'll be AM. If we get a 1, it'll be PM. But we can use some human readable identifier that gives us semantic information that we need. So we now created a definition of our structure, and we could create instance of it right here. We'll say like European time, and we'll create that now here. So if we run this, and we just put in like some dummy statement, hello, just to give us something to break on. Now if we make this and debug this, breaking at 18 and, oh wait. So now we can look, we have print European time. And this is a structure where we can see we have hours of 0, minutes of 0, seconds of 0, time of day, AM. So it's because we've instantiated it here, it essentially everything gets zeroed out. I generally don't use this way of instantiating structures very often. I just personally don't think it's that neat. I like to keep my definitions and my instantiations separate. And so here what I'm going to do now is I'm going to actually define the same thing, European time, and I will set it to what the time is here. So I'm going to need a struct time info. So this is my data type, and I'll call this European time. And now I can, as we saw in the slides, I think these come up in, here we go. This is how I instantiate the members. And so I can either, for instance, use the 0, and like in this notation will zero everything out and do the exact same as what we got before. So we'd have this representation. Or we can actually set the individual members. We can set one of them, two of them, all of them, none of them, what have you. it's up to you. But for instance, we want to set this to be roughly what the time is now. So it's 12:15 after lunch. So we're going to say, okay, the hours, this is going to be 12. The minutes, it's 16 past 12. Oops, forgot the dot. And the seconds, I have no idea, doesn't show, so we'll just say like 40, right? And then we can say .am, PM, or what do we call it? Time of day equals, it's PM now, it's after lunch, so we'll say PM. Do that a quick format, and then we can do the same thing again. We'll just make it, make, and debug it, and we'll break on 19. And now we can print European time, and we'll see that we've got a structure, hours 12, minutes 16, seconds 40, time of day PM. Now you'll see these little representations here, and all that is because we're using characters, and so sort of default interpretation of it is that we're wanting to store ASCII values. So we don't actually care what it is because the character memory is just 8 bytes, and whether we actually print it as a character or just use it as some decimal sort of integer value is up to us. So now we have a instance of our struct, right? And so now we want to say, okay, let's go and like change the time. So we'll create a function to randomly set hours. Actually, that's probably a bit too much. We'll just say increment hours. And so what we want to do here is we want to access the hours member of the function and increment it, use like plus. So we will then say, okay, cool. We want to take European time because it's a global variable, so I have access to it in this function. And I want to use the dot notation, and my you complete me Vim add-on will tell me, yeah, cool, okay, this structure has these 4 members. These are what I can access. So I can access the hours and then just go plus, right? And so it's going to increment the hours, and then we can void increment seconds. Do the same thing. European time dot seconds plus, right? And we may as well, for completion's sake, so increment mins void no. So now we have 3 functions to set or increment the seconds, the minutes, and the hours. So the other thing that might be useful for us is to have a function to print the time, right? And so this will just call printf, and it will say, okay, cool, I want the hours. So this is a character, but we'll print it as an integer so that we don't get the this /f being printed. We'll get then a semicolon, then we'll do the same, so we'll do the minutes, and then we'll do the seconds. And so we're going to say new line. Now we'll typecast these so that the compiler knows that we're not actually interested in this ASCII, but it should give us a decimal integer value of the character. So we'll say European time dot hours, and we'll just do this a couple more times. Dot minutes, and then dot seconds. Now we're at the point where if we run this, for instance, now, and we just run it once, print time, it should just return to us on exactly. Oops, I put a comma in there instead of a instead of a colon. No, not a semicolon, a colon. Right, cool. So now we can print the time. It should probably, we'll firstly print the time, increment the hours, increment the minutes, and then we'll print the time again. Right? So we should get now 12:16, and then we'll get 13, 17, right? And so we haven't done any logic in that once, like the next hour after 12 is actually 1. But we'll see here. So it's incrementing the values and putting them up. But now we want to have AM or PM. And so maybe we can make our increment hours a little more sophisticated. And we'll say, okay, I want to increment it. Or firstly, I'm going to go mod 12. And then mod equals 12. And so I believe this will give us it will roll over to 1. There we go. So we can do the same thing for here, European dot minutes, and then we'll mod this with 59. So the maximum value that the minutes can take. Mod equals, and seconds will be same thing again. Mod equals 59. But the thing we don't have on our printing representation is we don't have the AM or the PM being handled. So what we can do is maybe just do 2 separate print statements. We'll remove the new line, so the second print statement happens at the end of the same line, and then we'll just do a conditional statement. So we'll say if, now we need to read the value, no, we're not setting it, we'll say European time dot time of day equals AM, right? Then we want to printf AM, new line. That's it. Now we can just simply say else, because otherwise it will be PM, else, so we'll just go down to else, printf PM, new line. Now we can say, for instance, if we increment the hours and if European time, or sorry, if the time mod 12 actually, if it goes from 12 to 1, then this means that the AM PM should switch. So this is, we can add this in as well. So here we're doing, we're actually doing a mod of it, but what we want to do is say, when does this happen? So we'll say previous time equals previous hours equals European time dot hours, right? And then we can say if previous hours is greater than European time dot hours, this means that we've sort of overflowed and we've gone from 12 back to 1, right? And so what happens then is we can say European time dot dot time of day not equals, or wait, not equals European time of day, I think. Not an operation I use very much. So we can make this, oh, I'm forgetting a semicolon. Oops, PM, so this is obviously not working. Previous time. Oh, inequality. Sorry. I think this one is the one I want. No. Man, sorry. This was a stupid moment for me. There we go. So now we can see it's going from 12 and it's rolling over to 1. Beautiful basic example. So hopefully this sort of outlines the structure. We're going to go in and see a bit later in how we use a structure when we're dealing with pointers, because structures become a little more complex to use when we start dealing with dynamically allocated memory. So.